Hi, I'm Drewman. Welcome to my modest mansion. So today we're going to be swapping out the thermostats in my children's room. That one there. Here in our house we have in-ceiling electric radiant heat made by Thermaray. And it's basically just a piece of sheetrock that they embed a wire into that sits on top of the sheetrock up in the ceiling. And it radiates down. They say it's supposed to be better than the baseboard electric because that heats the air. The radiant heats the objects in the room. So far we like it. It seems to work pretty well. But our house is full of these old thermostats. You can't tell what you're actually setting it to. This one here keeps on sticking. So we'll come into her room and it'll be like 90 degrees. We're gonna be replacing them with these Honeywell non-programmable thermostats. There aren't a lot of options for those of us with electric heat. These line thermostats are expensive and there's only one option if you want a Wi-Fi thermostat and it's like $90. And I can't imagine spending $90 and having to buy 12 thermostats. There's only like a few programmable type ones and the reviews are all say that they're really clunky to program. So I think these will work just fine. What I like about these over the old clicker style thermostats, these ones here are just on off. So you set it to a set point, clicks on, gives it full power. These ones here, they actually reduce the power the closer you get to your set point. So if it's starting to get a little cold in the room, it'll just turn the heat on a little bit. And then as it gets further away from the set point, it'll bump the heat up. So they're more variable. So I think they'll be a little more efficient than these guys here. That's probably good for it. So when you're replacing these thermostats, they all come with a rating on them. Seemed like most of them were 1,000 watts at 120 volts or 2,000 watts at 240 volts. Having the in-ceiling radiant panels, I don't know how many panels there are and I don't know how many watts each panel is. There's a couple of ways that you can tell without having to climb up in the attic. So we haven't shut the power off yet. We're gonna go ahead and pull this thermostat out of the wall and do some tests. So I don't know if you can see that or not, but you gotta be careful when you're pulling apart someone else's work because not everyone does it like you do. And that wire is hardly underneath that wire nut. That right there, especially on electric heat, is a fire waiting to happen. Whoa! Busted down the door. All right, so we're gonna take our meter and we're gonna set it to amperage. We're gonna clamp it around. This is just a 2-wire thermostat and we're gonna read the amperage. So the heat is currently on and we're reading 11.9, so 12 amps. So weirdly enough, I just clicked it off and then back on, and now we're at 14.8 amps, which seems like a lot for a 20 amp breaker. So now we're gonna take that measurement. I open the Ohm's Law application on my phone. 240 volts, 15 amps. Holy cow. 3.6 kW. So we're actually sitting at 233 volts. So we're looking at 3.4 kW, which is way more than 2000. So this thermostat's not gonna work for this room. This is a big room though. So that kind of sucks. I guess we'll pull one out of one of the other rooms and put it in here. Hopefully Emerson's room is a little different. Daisy, your room's gonna cost us a lot of money to heat. All right, so this room's a little smaller. So I'm hoping that it has fewer panels in it, that this thermostat will work for in here, and then we'll take this is the same thermostat as out there, take this one over into her room. It helps if you change the meter over to voltage when you're checking for voltage. I swear the heat works in this room, which is weird because this would indicate otherwise. This was supposed to be a 10-minute job. Yeah. Alright guys, so we just got this figured out. Kind of. We know what the issue is now, we still have to figure out where the cross is. So we know the heat in this room has worked because we've been using it. It's been cold. My 5-month-old son sleeps in here, so we don't keep it freezing in this room. So we know the heat's been working in here, but the heat has seemed kind of funny. Like sometimes his heat isn't working, sometimes it does. Just now when I came in here, I couldn't get any amperage to flow through this, which indicates that the heat isn't working in this room. And then when I checked voltage, I only had 119 volts and I couldn't get 240. These heating elements, they're basically just a wire, so voltage will flow through them. So these thermostats only break one side of the 240, so 120 volts can still flow through those and end up coming back on the other side of the thermostat. So I had 119 volts on each of these, but I couldn't get 230, 240 on anything here, which indicates that we're only getting one leg of the 240. So I shut the power off.
Hey, it went off.
Just to see, you know, maybe we burnt up the where the breaker stabs into the bus. I've seen that before. When I turned this off, her room also went dead, which means that these two are on the same circuit, and I just had 230 in her room, feeds into her room through that box and then comes over to his room and goes up to the heating panels. So turned it back on, and I turned her heat on, because before we left that room I turned the heat off, and as soon as I turned the heat on in her room, we're now pulling 6.6 amps. Somehow they have it wired up so that it goes through her thermostat up to her heat and then over to his room through his thermostat and up to his heat. So in order for the heat in his room to work, her room has to currently be calling for heat. So we need to fix this because that is an issue. And that could also be why we had such a big current draw in the other room. If both of these thermostats were calling for heat, 6 of those amps were coming from his room, so his room or her room might not be as thirsty as we thought. Yep. So if we shut his heat off, hers drops down to 8 amps. Perfect. We should be good then. So at 8 amps, it's 2.07 kilowatts. So it's right around 2,000, I'd say. It's probably okay. And then his room was, we'll say 7 amps, so 1.6 kW. All right, so I think we're good to put these thermostats in, but we do need to figure out why his room is feeding off of her room. I think they just have some wires crossed in the box over there. So we'll go shut power off, we'll pull some wires apart, and then do some testing. So I have 3 different 12-2 Romexes coming in. One is going to go to the heating panels in this room. One goes over to my son's thermostat, and the other one is going to be your home run feeding power into this box. So we're just going to figure out what goes where and hook it up properly. I have my son's thermostat currently off. The 2 of these lines should have no reading, and one we should be able to have some resistance from the heat panels, which is another way you could tell how many watts your panels are. So we're going to set our meter to the ohm symbol, and we're going to start ohming these out. Nothing there. We have 28 there. We have nothing there. So the one on the right top is feeding the heat panels in her room. Now I have his thermostat on, so one of these other ones should read. So top left, 36, 35, and 26. So you could use those numbers too to enter into your Ohm's law calculator. You'd enter 230 volts, 26 ohms, and that'll give you the amperage draw, the wattage, which is pretty accurate. When you enter in 26 ohms, it gives you 8.8 amps. So that's the other way that you could do it to determine what the wattage is in your system. Just get the resistance across your heating element and go from there. So that's his room, this is her room, this is power feeding it. I'm gonna go ahead and tie whites together again. Something like heat, something that's high amperage for extended periods of time, you really want to make sure that you got a good connection. So make sure you twist your wires together real nice. I don't like using the yellows, especially on something like heat. The ones that Honeywell sends look a little more robust than most yellows, but still. These Honeywell thermostats are just a 2-wire, and they can be used for 120 or 240, it doesn't matter. And I don't think it matters which one goes where. So you just tie one to one and one to the other. All right, let's go put his in. When you're twisting a stranded wire to a solid wire, you want your stranded wire to stick just past the end of your solid wire. Because if you don't, the stranded wire might not catch and it can pull out easier. Like I've said a few times now, with electric heat, you want to make sure you got a good connection. Because if you don't, it's going to be a source of heat. It's going to start to heat up and get really hot and then melt. Melt the wire nut. Catch on fire, burn your house down. That's not a good thing. Twist them up really tight and then give them the tug test. That's kind of handy. That little tiny screw doesn't come out of there. Make sure you got it level before you crank her down. Just remember, if it looks straight, it is straight. Try to cover your, make sure the hole is covered also. Alright, we're going to go ahead and turn this on and make sure that we got that issue fixed. Oh crap, how do you change it from Celsius? Holy cow, we're set to 67. So we shut her thermostat off and his is still cooking by the looks of it. So I think we got that issue fixed. Must have had a wire in there crossed. Hey, give that back. Hey. Set his heat to 64. Should be warm enough for a baby, right? Daisy, whatever you're doing, stop. Leave those alone. Give them to me. Drop them. Drop them. Drop them. Drop them. Let go. Drop them. Oh. All right, run along. Play. So her heat is currently off. We should have 0 amps. We kick that up now. There we go, 8.35. We'll kick that off again. And this one should have 6.6. No. Our children, great. She's over here sticking my screwdriver in an outlet. Good job though choosing the neutral. My girl. What did you just say? When you have the cover off like this and the power on, just be careful because 120 volts right there. And that probably hurt. Never a good day when you get your ears tweaked. All right. That's done. All right, so there you have it. That is the thermostat install. It's a pretty simple job. You can probably do it at home. If you're really uncomfortable with electricity, you really don't know what you're doing, hire a professional or do like a lot of research, because that's how you end up with issues like this where the heat has to be on in this room for that room to work. And now you're pulling way more amps through one thermostat than you should be. Things just don't work properly. So either hire someone or do a lot of research if you're that uncomfortable. Electricity is dangerous. You can really do some damage if you don't know what you're doing. Definitely glad I changed these out and found that issue, because now things should work a lot better. There were nights where we didn't turn the heat on in her room, but we turned it on in his room. We were like, man, I don't think the heat's working in here. Now it all makes sense. I think these thermostats will be better for us. They're gonna modulate how much power is going out to them, so they'll hopefully save us a little money, because we haven't gotten an electric bill yet with the heat on, so pray for us. Thanks for watching. If you liked the video, go ahead and hit that thumbs up button. If you really liked the video, consider subscribing. We'll see you in the next one. Have a good day.